Let's take a look at problem number 8. Now, problems number 8 and 9 require us to really analyze the information that's being put here. And this is something that I'm going to always stress in our class is that we need to take words and translate them into functions, expressions, equations. And in this particular case, we have quite a bit of information that's given to us. And now we just need to know how to align these things so that we can get the answers that we're looking for. Okay, so let's take a look. It says the distance that Miss Winfield travels on her bicycle. She goes at a constant speed, very important. It's always a constant speed. So the distance that Miss Winfield travels on her bicycle is a function of the time she has been riding. And here is a table of this function. So we have, remember we were doing this in our examples when we were talking about the physical age and the mental age, and we said that the mental age, okay, was a function of the physical age, right? And here now we have the distance is a function of the time she has been riding. So what do we mean by this? Well, he says there's a relationship to the distance and to the time. Um, so at a specific point in time, there's a certain distance that she has traveled. So if we were to look at, I'm not going to draw the entire table, I'm just going to put here that we represent the number of seconds as S, okay, and the first value we have is 15, so that's 15 seconds, and the distance we're doing in meters, okay, the number of meters traveled, and that value that corresponds to 15 is 165. So now we're asked, what is Miss Winfield's speed in meters per second? Okay, well, meters per second is simply the meters divided by second, right? Like miles per hour. And what we would do is we would divide 165 by 15. Okay, so we know that if we were to do that, we would have 165 divided by 15. That would be the meters per second, let's just say, if we were to write it this way. All right, that's meters divided by second. And that would be 165 divided by 15, and the answer would be 11. So we'd have 11 meters per second. Okay. So that is her speed as it relates to this table. Okay, remember, we're going with the information that we have on our table. Now, if we were to write a formula for this function, how would we write that? Well, remember, we have to take a look at what values are we discussing here, and what in particular are we looking for. If we were to write this as a function, uh, we have to look at the distance being meters, right? Um, and let's see, meters. Let me write it over here. Meters is equal to what? We did this before. What would the meters, we're writing this as a function. So M as it relates to S in this particular case. Now, we would need to look at the rest of the table to make sure that this works, okay? But we already know that it's constant. I don't want to move along too fast, but I can just tell you that what we did here is going to be her speed all the way through. Because if we looked at 30, okay, I believe 30 was the next one, it was 330. And what's 330 divided by 30? Well, that would be 11. Okay, so we know that this is 11 times, excuse me, this is 11 times this, meaning the distance is 11 times the time. I'm using that word twice there. Don't want to confuse you. So we would be able to represent this as 11s. In other words, we would multiply s by 11 to determine the distance that she's traveled. So that would be the function. And remember, we did that with the example that they showed in the beginning when we went through the lesson, and we were discussing the mental age and the physical age, and we were saying that the physical age, or rather the mental age, was 2 times the physical age. So this is really no different than what we did there. Okay. Now we're asked, how far would Miss Winfield go in 70 seconds? So having this function, we can now determine, well, in 70 seconds, how far would she go? Now, our table went out to 60, but if we had 70, we can go ahead and plug in that value and say that the meters would be equal to 11 times 70. Remember our parentheses, and we put our value in, and 11 times 70 is equal to 770. So she would travel 770 meters in 70 seconds. So there you have it. That's number 8, and we'll move on to number 9 in our next video.